Presentation by Group 9 of UEMH 4143 UTAR. Now are showing the isometric view, top view and front view of the system. The system can be identified as three major sections. The first major section is the shaft feeding station at the top. The second is the conveyor at the bottom, while the third section is the sorting section at the most right. And continue by the exploded view. Shaft feeding station. Conveyor. Post-assembly sorting station. And the final assembly of whole system. First, load the holders and shaft into the system. This is the actual performances of our prototype. The continuous assembling of shaft are able to perform under condition of discrete or continuously position of shaft. The designed locus and slide weigher make the shaft able to drop down one by one perfectly. The following clip is showing the way of taking out the successful assembled holders and shafts. After the sorting process, the shaft and holder are kept in the container and remain the assembled condition. Post-assembly sorting. The shaft is intentional not place in the shaft feeding station initially, to make the holder fail to assemble. The assembled holder and the empty holder are successfully sorted into the two separated compartments. Motion analysis. All the design are being tested with the engineering approaches where the motion study, and the gravitational action of the prototype had been studied. After a few trial and error with the heuristic method and SolidWorks simulation, we finally get the final design with optimal result. Shaft feeding station. This our initial design. With a narrower body width, the shaft is being stuck, if only driven by gravitational force. A failure is occur. The problem is solved by increasing the body width as shown, to allow the shaft to some turning angle in order to slide down the channel. Linear guide of conveyor. The linear guides on the two sides of conveyor are for the purpose of correcting the orientation of the holder. It had been tested that even when the worst case happened where the holder is placed by 45 degree, it's still able to move forward smoothly and corrected by the linear guide without being stuck. Sorting station. An extra feature is introduced into our system to do the post-assembly sorting. This container is composed of two compartments. The first compartment is for collecting the successful assembled holder and shaft, while the second compartment in the other hand is for collecting the holder and shaft that are fail assembled. Initially the sorting container is mounted on higher position and with a lower level of inclination of the sliding plate. Unfortunately, this combination does not make the empty holder slides into the second compartment. With some of the adjustment, where the mount position of sorting container is make higher in place, and also higher degree of inclination for sliding plate, the empty holder is now able to slip into the second compartment without any problem. Although the collected holder and shaft will be flipped by 180 degrees, the computed impact is verified that it would not cause any disassemble of holder and shaft to be occurred. The cover at the bottom of backside can then be opened, to take out the sorted parts easily. Schematic diagram. This is the wiring schematic diagram of our prototype. As shown in the schematic diagram, the system uses two stepper motors, one servo motor, one vibrator, two IR sensors, and one LCD display. The potential meter is nothing but just for the purpose of adjusting the right contrast of the LCD display. For the two stepper motors, they are connected to an external power source of 12 volts in order to generate higher speed and torque since Arduino cannot supply enough power to them. Flowchart. The following shown is the flow of our system. Since Arduino code or Mega board can only process sequentially, hence the system cannot function or control multiple components simultaneously. In order to solve this, the system is coded in such a way that it appeared to run in simultaneous fashion. From the beginning, when the program is started, IR sensor 1 will check is there any holder in front of it. If no holder is detected, it will move conveyor by one step, and then keep detecting between every single step of conveyor, and keep looping inside until the holder is detected. After the holder is detected, it will break the loop and start to do assembling. When assembling, the conveyor motion will be turned off in a short period. The stepper motor of the shaft feeding station will rotate about 45 degrees to drop off one shaft. The predefined assembly time is around 2 seconds, to wait for the shaft to fall into the holder by gravity action. After assembling, the next action is to check whether it is successful. The conveyor is first moved by some steps away from IR sensor 1 to avoid the same holder being sensed again. In this session, the IR sensor 2 will detect whether the shaft is present inside the holder after the conveyor executing each single step, which is similar to IR sensor 1 in previous session. It will keep sensing until the shaft is found or until exceeding the position of IR sensor 2, which is represented in time domain. Finally, based on the IR2 result, the total number of success and failure will be printed on LCD screen, and change the servo motor angle for sorting successful assembly or failure assembly. The program will keep looping to detect next set, and can function pretty well for both the case of coming holders as separated or all sticking together. Bill of Material, BOM. The BOM is showing all of the components and costs that are spent in this project. For the mechanical part, the cost is around 100 ringgit. While for the electrical and electronic components, they are cost around 50 ringgit. The sum up total cost is around 150 ringgit, which is quite cost-effective. Design advantages. With this given design, it is able to support up to maximum 10 pairs of holder and shaft. Room of improvement. Since the main objective of this project is just simply assemble the shaft into the holder, and do not need to care about the necessary of the final product be assembled. But in real situation, it is not preferable since the manual load back for the fail-assembled shaft and holder involved a lot of labor. Hence, there is some room of improvement for our design. With this proposed closed loop of the system, the individual holder or shaft will keep looping inside the system until they are assembled, which make the system now to be fully automated. Thanks for watching.